Alright guys, in today's video we will look at significant figures, and with time you'll see me using SF for significant figures. So let's say we have these small numbers A, B and C. In fact, how many significant figures do we have in each? Before we start, I believe you are now starting, but pause the video and give it a try first. And if you get it wrong, don't worry, you use this example right here to explain everything. If you are done, let's get right into it. In fact, with this first example, we have two significant figures in it. What about the B? With the B, we have four significant figures. What about C? With C, in fact, we have five significant figures. But the question is, how did I come out with all these number of significant figures? Let's use this example right here to explain. Now, these zeros right here in front are known as leading zeros. So let me write it. They are known as leading zeros. And one key thing about leading zeros is that all leading zeros are not significant. So if you look at case 1 right here, all these are known as leading zeros, which are not significant. The only significant figures we have in this number right here is just 1 and 8. That is how come we had two significant figures for the whole of this. Now let's consider the second example. This right here, we also have leading zeros which are not significant, yet we had 1, 2, 3, 4 as significant figures. All right, so that brings us to this part. Now, these zeros right here are known as trailing zeros. Now, there are two important things about trailing zeros. Trailing zeros are significant if there is a decimal point. That is case 1. And case 2, trailing zeros are not significant if there is no decimal point. So with the first case, we can clearly see that with this example right here, we have trailing zeros in it. That is actually two trailing zeros, right? Now, because we have a decimal point right here, it makes these two trailing zeros significant. So to talk about significancy in this number right here, we have to obviously start from the non-zero right here, which is 1. So we have 1, 2, 3, 4. That is how come we have four significant figures. All right. Now let's consider this 0 right here. In fact, this 0 is between two non-zero numbers, that is 8 and 5. This is to say that all zeros between two non-zero numbers are significant. Therefore, this number right here is also significant. But the question is, how many significant figures do we have in this number right here? And to do this, in fact, we have to start counting from the left to the right, starting from the non-zero number. Remember, even if there is a decimal point right here, so these zeros are still leading zeros, of course. So we have 1, 2, 3, 4, 5, 6. So with this one, we have 6 significant figures. So the key thing to identify when it comes to significant figures, especially smaller numbers like this, you have to first consider leading zeros, zeros between two non-zero numbers, and trailing zeros. And like I said, two conditions. Trailing zeros are significant if there is a decimal point, right? If there is a decimal point. Again, trailing zeros are not significant if there is no decimal point. So now that we have these key things, we can just start solving examples. So I'll get rid of this quickly. Let's say we have 4.973, number like this. And maybe we want to leave this one in just one significant figure. How are we going to do it? Let's consider the question. So to leave this one in one significant figure, of course, we have to start counting from left to right. And if we start counting, this will be the 1, right? Now, you just have to identify where you landed, which is 4 in our case. Then you consider the number that is next to that. The number that is next to the 4 right here is basically 9. And always, let's say the number that is next to the number that we landed on is x. Now, if that number is greater than or equal to 5, then we add 1 to the number that we landed, all right? Now, if that number next to the number that we landed is less than 5, then we are basically going to forget about it, right? So with this one, we see that we landed on 4. The number next to the 4 is 9, which is greater than or equal to 5. If that happens, then we are going to add 1 to the number right here. In the same way, if it is less than 5, then it means that we are going to leave it like that. We are not going to do anything to it. We just throw it away, right? So this 9 is more than 5, so we have to add 1 to this, making 5, and we are done. Of course, if you try to bring 0.000, remember these zeros are trailing zeros with a decimal point, which are also significant. So if you try to convert these to zeros, then actually you are talking about 4 significant figures right now. All right? Yeah, so now that we understand this one, with the same number, let's say we want to leave it in probably, let me say this is one significant figure. Now let's say this time around we want to leave this in 2 significant figures. Of course, we have to start counting from left to right. And to do that, we have 1, 2. We just landed on the 9 right here. Of course, don't just write the two of them, but consider the number that is next to that. And we can see that the number that is next to 9 is obviously 7. 7 is greater than 5, right? So we have to add 1 to this. And of course, if we add 1 to this, we are going to have 10. But we can't write all the 10 right here. So what we will do is that we just run it again, then we'll have 5.0. And this time around, this is going to be 2 significant figures. Now, the cool way to understand this one is that sometimes students make these mistakes. When they run and they get 10, they find it difficult to simplify. This is how to do it instead. Now, if you have a situation like that, you just have to write the 2 digits first, like this. So we have this. Then we want to add 1 to this 9. So basically, bring that 1 right here. And then do the basic mathematics. We have 9 plus 1, that is giving us 10. Of course, base 10, we can't write all the 10 there. So we write 0, remainder 1. Then we have a decimal point, bring it there, right? Then we have 4 plus the remainder, which is 5. So we have 5 here. So we have 5.0, which is 2 significant figures, simply because we have trailing 0 with a decimal point, which is also significant. See that? So pretty much simple. All right, so now that we have this idea, we can keep on doing some examples. So again, let's say we have 15.0073, and maybe we want to leave our answer or this number right here in 3 significant figures. How are we going to do it? Now, to leave this in 3 significant figures, of course, we have to start right from here. We have 1, 2, 3. We landed on this 0 right here. Okay, now the number that is next to this 0 is still 0, which is obviously less than 5. Therefore, this number in 3 significant figures is going to be, and this is in 3 significant figures, as simple as that. With the same number, let's say we want to leave this in probably 4 significant figures, then we are going to have 1, 2, 3, 4 on this number. Now, the number that is next to this 0 is 7, which is more than 5. So we add 1 to this one, then we will have 15.01. And this is in 4 significant figures. Pretty much simple, right? So I believe now if you're given any decimal number and you're asked to run it or leave it in a certain significant figure, basically you can do it. Now let's consider whole numbers. Let's say you are given a whole number and you are asked to, let's say we have 8, 7, 6, 0, 1, 6. In fact, this number is 876,016. And maybe we are asked to leave this in, let's say, two significant figures. Let's say we want to leave this in two significant figures. Of course, always we have to start from the left and then count to the right. So 2, we have 1, 2. We just landed on this 7 right here. And remember, the number that is next to the 7 is 6, which is more than 5. If that happens, then we will run it. We will add 1 to this. So we are going to have 8, 8 this time. But are we going to leave it like this? Remember, this number is somewhere around 800,000. So it means that if you leave it like this, which is 88, then you have obviously reduced the number from each state to a very small state, right? And that makes it wrong, right? So to do this, what you have to do is after changing this one or running the next number, you have to leave all these numbers in zeros. So we have 1, 2, 3, 4. I'll just put those zeros there and realize that still we are around 800,000. Okay, now the key thing you have to note here is that when it comes to whole numbers, after identifying your significant figures, you have to change the remaining digit to zeros. Unlike the decimal numbers where we forget about all the numbers after identifying your significant figures, with this one, of course, you have to change all the digits that are remaining to zeros. All right. Now, with the same example, let's say we want to leave it to maybe four significant figures. So let me write four significant figures. With this one, of course, we have to start counting. 1, 2, 3, 4, right? We just landed on this number right here. And we see that the number that is next to this 0 is obviously less than 5. So we are going to have 8, 7, 6, 0. Then we change this one also to zeros as well, which will be 0, 0. And of course, we are still in the range 876,000. Okay, now let's consider another example. Let's say we have, this time around, I'll use red marker. Let's say we have 2,0,053. So this is around million, right? 2 million. If I put comma here, we are around 2 million. And we want to run this one or leave this one in maybe four significant figures. Of course, this is going to be 1, 2, 3, 4. We just landed on this one right here. The number that is next to the one is 6, which is more than 5. So we have to add 1 to this, making 2002. Then we try to change all these to zeros so that we will have 0, 0, 0. And we can clearly see that still we are in the million column, right? So that is basically how to run whole numbers to a given significant figures. Now this time, let's consider numbers in the standard form or numbers in the scientific notation. Let's say we have 2.693 times 10 to the power, let's say 4. Let's say we have this number, right, in scientific notation, and we want to leave this in two significant figures. So two significant figures. Let's say we want to leave this in two significant figures. Now to do this, of course, don't pay attention to the 10 to the power something something. Don't pay attention to that, but just pay attention to these decimal numbers right here. Of course, with this, you start counting from left to right like we know already. So we have 1, 2. We just landed on this 6. The number next to the 6 is 9 more than 5. So we add 1 to this, making 2.7 times 10 to the power 4, and you are done. Now remember, we have a decimal point here. If you try to convert or change all these numbers to zeros, you are going to end up getting two trading zeros with a decimal point, which are also significant. So in this case, it is going to be 1, 2, 3, 4, four significant figures, which is obviously not two significant figures. Therefore, you are wrong when it comes to that, right? So you have to pay attention to that very well. Now, with the same number, we want to leave this in just one significant figure. To do that, we have one right here, right? Counting from this side, 1, we are on this number. The number next to that is 6, which is more than 5. You run or add 1 to this one, making 3. So we are going to have 3 times 10 to the power 4, and you are done. Okay, now if you put a decimal point like this without writing anything, it is still correct. But as soon as you add 0 to 8, it's not in one significant figure anymore. Therefore, we have 2 because of this 0. Trailing 0 with a decimal point, it is significant. So this is now in 2 significant figures and not 1, right? So that is that. But you can choose not to bring the decimal point and you are still correct. Let's consider another number. Now let's say we have 0.0767, and maybe we want to leave this in just one significant figure. What is it going to be? Now with this right here, in fact, these are leading zeros which are not significant, so we have to start right from here. So 1, we are just landing on the 7. The number next to the 7 is 6 more than 5, so we have to add 1 to this, making 0.08, and you are done. Remember, these 2 zeros right here are here to help us maintain the value of the number. If you try to forget about it, remember this number right here is not even up to 1. If you forget about it like this, we are somewhere around 8 going, right? You have obviously added some numbers which are not supposed to be added to that. So to maintain the value of the number, of course, we have to bring 0.00. After all, we know that these are leading zeros and they are not significant.